Okay, we're going to do a few problems here, starting with page 591, number 32. We want to figure out the area of the shaded region here. This happens to be a segment, but with 32, what we're going to do is basically, to figure out that shaded segment, we're going to figure out the area of the sector in its entirety, and then minus out the triangle that's in there, and you're left with just the shaded segment. And that is the logic. We're going to minus out the triangle. So we're going to figure out the area of the whole thing, minus out the triangle part, and you're left with just the top part. So with the sector, there's 90 degrees here, so this is 90 degrees. We would say 90 over 360, and then multiply it by the entire circle, which is pi r squared. Pi r squared would give you the entire circle. This 90 over 360 is 1/4 of the entire circle. Oops, multiply that. And this will end up being 16 pi, multiplying that out, 50.26. That's the entire shaded region. But we want to minus out this triangle, which is 1/2 base times height. So it is 1/2 8 times 8. 8 times 8 is 64. 1/2 times 64 is 32. If I minus 50 from 32, you get 18.26, or approximately 18.3 meters squared for the shaded segment. Number 32. Okay, this is number 33 here. We have two shaded parts, and we're going to figure out the area of the shaded parts. You can go about this one of two ways. You could figure out the area of this sector and then this segment and add them. Or what I'm going to do is figure out the area of, this is half a circle. So what I'm going to do is figure out the area of half a circle as if everything is shaded, and then I'm going to minus out the one little triangle here, and then you're left with half a circle minus the triangle, which would look something like this. So then you're left with the shaded part, the half a circle minus the triangle. So half a circle, of course, is 180 degrees. You can put this 180 over 360, multiply it by the area of a circle. The radius is 6, so pi 6 squared. 1/2 times pi, 6 times 6 is 36. This, of course, is 18 pi. 18 pi is approximately 56.54. So if everything was shaded, 56.54. We're going to minus out this triangle. Now this triangle is not a traditional base times height triangle. This is 6, this is 6, because that's also a radius, 120 degrees. We're going to use this trig formula. 1/2 a side length times a side length times sine of A. So 1/2 side length 6, side length 6, sine of the angle 120. Throw that in the calculator. I'm saving time here. This is 15.58. You minus out the triangle. You're left with the two shaded regions. 56 minus 15 here is 40.95-ish. And this is centimeters squared. Number 33. All right, now we're going to go to the other review of Chapter 12 here, page 710. We're going to start with number 2. You've got a tangent line, you've got a radius. The tangent line and radius makes 90 degrees. They want you to figure out this little sliver outside the circle, x, there in yellow. We're going to use Pythagorean theorem, and what we're going to do here, we know here to here is the radius, and if this is the radius 32, this is also 32. What we're going to do is do this. We're going to treat this, of course, like a right triangle, but this is 32, here's the right angle, this is 24, and what I'm going to do is just figure out this entire thing here, and I'll just use the letter y. And then once I know this entire letter y, what I want to do is, y is basically the 32 plus the x. So whatever I get here for y, I'm just going to minus the 32 from it, and then I'll solve for x, which is just this outside portion here in yellow. Okay, so then it's Pythagorean theorem here. 32 squared plus 24 squared is equal to the entire hypotenuse squared, y squared. If I do this correctly, this is 1024. 24 times 24 is 76. Add those two together. 1600 is y squared. Square root of 1600 is 40. So all the way across is 40. But here to here is the radius 32. And so the outside part, once I minus 32, the outside part, x is 8. 8. Now there's another way to do this, and that is, instead of making this entire hypotenuse being y, you could go, okay, well this thing really is x on the outside plus 32, plus that radius. And you could go a squared b squared off of this. And I actually did this right below here. So you can do the same thing. 32 squared, 24 squared, and then x plus 32 squared. Now this way is a little bit harder because just the algebra. You're going to do the box method here. You're going to get x squared plus 64 plus 1024 here because you've got a quadratic. You want to make everything equal to 0, so minus this number, you got it equal to 0. You've got a quadratic. You want to do the zero product property, looking for two numbers that multiply to 576, add up to 64, crazy big numbers, 72 and negative 8. You will get one answer here being negative 72, the other answer being 8. You can't have a negative length of the hypotenuse there. You can't have the number 8. So this number is 8, which of course is the same as doing the a squared b squared where the entire hypotenuse is y. Either way would work. Okay, this is also on 710. We're going to do number 8 here. They want us to figure out the measurement of arc AB. So from here to here. And that would be in degrees. What we have here is something 6 inches, 3 inches, but now all of a sudden we want to figure out a degree measurement, which is a lot more advanced. What we're going to do here is realize that in any circle, this central angle, if that's x, then the arc is also the same. The central angle and the arc are the same. And so what I want to do is figure out that central angle there, because we're in the center of the circle. So I'm going to enlarge that one triangle, focus in on this one right triangle here. Here's 3, here's 6. I'm going to figure out this x. And that x is right here. It's also on this side. And let's say if that's 50 and this is 50, then that together is 100, and then AB would be 100. But we got to figure out this x. Now these are 3 inches, 6 inches. We're going to use some trig here. If I stand here at angle x, this is opposite x, but there's nothing here. This is adjacent. The 6 is opposite the 90, so that's the hypotenuse. SOHCAHTOA, you've got to pick the correct one. With adjacent and hypotenuse, it's cosine. So we're going to say, we're going to say cosine of unknown angle x is adjacent over hypotenuse. Angle x is the inverse cosine here of 3 over 6. So when you go to your calculator, this should end up being 60 degrees. So this is 60 degrees on the right, 60 degrees on the left. 60 plus 60 is 120. 120 is the central angle. 120 is arc AB. So arc AB is 120 as well. Okay, trig.